Hello everyone, welcome to Programming Knowledge. Today I am taking the example of publish message format and also we will understand the different level of MQTT quality of service. Now let's get started. This is the message format of publish command of MQTT. The control packet type of publish is 3. So that's why the first 4 bit is written as 00011. And as we have seen in the previous lecture that in publish command control type flag bit is subdivided into DUP, QoS and retain. And the second byte is the remaining length. These 2 bytes consist of the fixed header. As we have seen in the previous lecture that this fixed header is always present in all of the command of MQTT. The variable header of MQTT contains the topic string length, topic name, and packet identifier, which is also a message ID. And lastly, payload field of publish contain the message which has to be sent. So, the topic name with the topic name string length consists of the name of the topic which the message is published, to which the message is published. The first 2 bytes of the topic name field indicate the topic name string length. Okay. Message ID, which is a packet identifier, as we have already seen the packet identifier properties in the previous lectures. So a message ID is present if QoS is greater than 0, that is QoS is 1, that is at least once delivery, or 2, exactly once delivery. We will see QoS in much more detail in the later part of the course. Now, publish message, which is nothing but an array of bytes. The structure of publish message is application specific. Now, let's see some important point about DUP, QoS and retain. DUP flag. If fresh or new published message is there, then it has set to be as 0. Or if it is a redelivery, then it has to be set as 1. QoS level. This flag represent the level of assurance for an application message delivery. 0 represent at most 1 delivery, 1 represent at least 1 delivery, 2 represent exactly once delivery. As you see in the table. Here 1 is reserved, which is not being used. Retain. If retain flag set as 1, that means that application message must be stored. If flag set as 0, that means that application message must not be stored. Now, let's understand the QoS in much more detail. As we have seen in the previous lecture that MQTT uses TCP/IP protocol for data delivery. But even though TCP/IP provides guaranteed data delivery, data loss can still occur if TCP connection breaks down and messages in transit are lost. Therefore, MQTT adds 3 quality of service level on the top of TCP. QoS level 2, which have semantics of exactly once delivery of message. QoS level 1, which have a semantics of at least once delivery of message. QoS level 0, which have semantics of at most 1 delivery of message. Level 2 is the highest level of quality assurance. Now, let's start with QoS level 0. QoS level 0, a message delivered with at most once delivery semantics. Messages are delivered according to the delivery guarantee of underlying network of TCP/IP. So, where this QoS level is used? Let us take an example of temperature sensor data. Temperature sensors data, which is regularly published, loss of an individual value is not critical, since applications will anyway integrate the value over time and loss of individual sample is not relevant. To understand the QoS level 0 more clearly, let's look at the message flow diagram. The client publishes message to the server and the server publishes message to the subscriber, and Without any acknowledgement is received, the message is deleted by the client. So the assurance that the data is received by the subscriber is very low. So that's why it is also termed as fire and forget. Now let's see QoS level 1. QoS level 1 afford at least one delivery semantics. Messages are guaranteed to arrive, but there may be duplicate. That is, if the client does not receive the acknowledgement command pubback in time, it resends the message. The application example of QoS level 1 is a door senses the door state. It is important that door state change, just like close to open or opens to close, are published lossless to the subscriber. Applications simply discard duplicate messages by evaluating the message ID field. Let's understand the QoS level 2 with the message flow diagram. Firstly, client store the message and publish the message to the server. The server store the message first and then publish the message to the subscriber. After some time, the server delete the message and send pubback acknowledgement to the client. After receiving the acknowledgement, the client delete the stored message. In this flow diagram, you have seen that acknowledgement work at one level, so it give more assurance of message delivery than QoS level of 0. Now let's move forward to QoS level 2. QoS level 2 affords the highest quality delivery semantics, that is exactly once, but comes with the cost of additional control messages. We have to use more than 2 acknowledgement. We will see. This is the highest level that also incurs most overhead in terms of control messages and need for locally storing the messages. It is important to note that exactly once is a combination of at least once and at most one delivery guarantee. The application example of QoS level 2 is where the duplicate event could lead to incorrect actions. Example, sounding an alarm as a reaction to an event received by a message. Let's understand the QoS level 2 using message flow diagram. Firstly, the client store the message and then publish to the server. Server stored that message and published to the subscriber. And after that, the server sends the pubback to the client, pubback acknowledgement to the client, and thereafter the client sends the pubback acknowledgement to the server. After receiving the pubback, the server deletes its stored message and send pubcom acknowledgement to the client. The client receives pubcom acknowledgement and delete its stored message. As you can see here, the acknowledgement level is more than 2 and hence it assures the exactly once delivery of message. That's why it is the highest level of quality of service. So thank you guys, and